All right, we want to talk a little bit about inverse functions. So what are inverse functions? So we have to think, so first off, we already know that a function and I used the abbreviation FCN for function, is a mapping from the real numbers to the real numbers whose graph passes the vertical line test. Okay, so we know that if we have something that looks like this, all right, so that's going to pass the vertical line test. All right, whereas if we have something that looks like this, this is going to fail the vertical line test. Okay, so this one is a function. And this is not a function. Okay, so now that's basic. Okay, all of that is easy. Oh, I forgot to go over our learning objectives. To determine the conditions for when a function has an inverse, to use the horizontal line test to recognize when a function is one-to-one. To find the inverse of a given function, draw the graph of an inverse function and evaluate inverse trigonometric functions. So that's what we're trying to do in this section. Okay, so we now know basically what is a function. Okay, so what makes a function? So we can talk about a function. A function is just a mapping, okay? So it basically takes a x and it sends it to a y. Okay, so we have some domain. We have some domain. And then we have some range. And so we can choose values here. And each one of these maps to something over here. Etc. Okay, so a function, this function f, what we want is f is going to take some x1 and take it to y1. So this function is going to be f of x. Okay. And then what we want to do is we want to be able to create, if it exists, the function that's going to, so how this function is going to take x4 and going to go to y4, that is f. we want to create some function that's going to be able to take y4 and go back to x4. So this function is going to be f inverse. All right, so that's the inverse of a function. All right, so if I take x1 to y1, then that's going to give me a value, but I want to make sure that I go back to the same thing. All right, so we say that a function is one-to-one. And sometimes you'll see it written like that, one-to-one. If I have two things, so if f of x1 does not equal f of x2, whenever x1 is equal to x2. All right, not equal to. So if x1 is not equal to x2, then their function values cannot be the same. All right, so let me give you a very simple example, okay? So here's the example. Here's my domain. And here is you and 4 friends. Okay. And you're going to a sneaker store. If you're not from Philadelphia or from the East Coast, you don't say sneaker, you say tennis shoe. But I say sneaker because I'm from Philly. Okay, so you're going to a store that sells sneakers. All right. And they already told you they have 5 particular pair of sneakers. All right. So based on your color you like, the size you wear, and the style, they've told you already that they have 5 sneakers that are available for you guys. Okay, so you get there. Okay. And when you get there, they say, okay, here's you. Well, let's say, here's your friend. This friend is going to get sneaker S2. And this person is going to get sneaker S3. And this person is going to get sneaker S4. And this one here is going like that. So you would expect that you would be assigned sneaker S1. But if you get there, I'll put it back. And they've assigned you and one of your friends to the same sneaker, you're not going to be very happy. Because you were planning on getting something and they have one box, but both of you have been assigned the same box. So this problem is not one-to-one. Okay, so this is not one-to-one. And the reason why it's not one-to-one is because it doesn't have one pair of sneakers for every one person. If you notice, this looks, so if I were to draw this as a function, let's draw it. Okay, So here is a similar way to draw it is, let's say I have, here's u, 1, 2, x3, and x4. So x1 is at S2. So that would be like here. And x2 is at S3. Oh, I want that red. And this one is up here, and maybe this one is there. But notice these two have the same value. So if this were a function, let's say this were a function, a continuous function, notice these two values are the same. So I have a value here going to, I have an x1 going to some f value. I have another x going to the same value. That's the problem. What does this say? If the x1 and the x2 are not equal, then their function values are not equal. So since you and your friend are not the same person, you can't be getting the same pair of sneakers. So let's draw it. So here's going to be what it really looks like. So if my function now I want a horizontal line. So if the function fails the horizontal line test, it is not one-to-one. So now let's go back. We already said we know something's not a function if it fails the vertical line test. So in order for it to be a function, it has to pass the vertical line test. In order for it to be a one-to-one function, it has to pass the horizontal line test. Okay, so let's write that out. So f of x can only be a function if it passes the vertical line test, and it can only be a one-to-one function if it passes the vertical and the horizontal line test. Okay, so let's say we look at this function. F of x equal x cubed. Okay, so this function, as we can see, is going to pass the horizontal line test and the vertical line test. All right. So this function is one-to-one. So now let's consider f of x equaling x squared. Well, we know what f of x equal to x squared looks like. That's the other thing too. If you buy that calculus quick study, it has all the basic functions on there as well, and all the trig values, everything. Okay, so this is a function, all right? It passes the vertical line test, but it doesn't pass the horizontal line test, so it's not one-to-one. All right, so if I draw a vertical line, we can see that on the interval f of x equal to x squared is not one-to-one. However, on the interval 0 to infinity, f of x equal to x squared is one-to-one. And on the interval minus infinity 0, f of x equal to x squared is one-to-one. Any questions about that? So that means if I'm only, I can't do this because, well, I can't do it. It's kind of weird. Can't do it that way. If by chance you're only, so if you put your hand down and cover the third and the second and third quadrant and only look at that first quadrant, you can see that from 0 to infinity, it passes the horizontal line test. And if I could take and cover the first quadrant and I only care about the second quadrant, I can see that it passes the horizontal line test. So this function is one-to-one on particular pieces, but as if I include the whole interval, it is not one-to-one. All right, why is this important? So we're going to have if, so if f of x is one-to-one on an interval, then f of x has an inverse there. On that interval. All right, so what does that do? All right, let's go back to here. So this is x1 and here is x2. Here is x3. This is y1. Let's call this z1 and let's call this w1. Okay, so f takes x1 to y1. F is going to take x2 to z1, and f is going to take x3 to w1. Actually, we don't even need the w's over here. Let's just make it y, z, and w. Okay. So that's what f does. So I know that f of x1 is y, f of x2 is z, and f of x3 is w. But because this function is going to be 1 to 1, I can see that F inverse is going to take y back to x1. It's going to take z back to x2, and it's going to take w back to x3. So now I have F inverse of y is x1, F inverse of z is x2, and F inverse of w is x3. So F will take x1 to y, and its inverse will take y back to x. So the inverse function is if you walked into a machine and that machine could make you 25 years older, and then you walk in the machine and it takes you back to being your age. It's an inverse function. All right, so it is true that F inverse of F of any x is going to be itself. Anything you pick, it's going. So F inverse of F of any x is x, and F of F inverse of any x is x. So if I start, so let's see. Let's say we start at x1. We take F of x1. That gives me y. So here I have F inverse of F of x1. So I need to compute this part first. So what is F of x1? Oh, I hate teaching without people talking back to me.
Y.
Yes, good. So F of x1 is y. So I have F inverse of y. But what is F inverse of y?
X.
X what?
X1.
X1. So see how F inverse of F of x1 gave me x1 back?
Mm-hmm.
Okay, let's do another one. Let's do F of F inverse of w. So now I have to compute this first. So I need to do F of, what is F inverse of w?
X3.
X3. And then what is F of x3?
W.
W. So an inverse function is going to reverse what you just did. Okay, so that's what an inverse function does. So the question is now, how do we find an inverse function? All right. So given, I'm going to actually write it like this now, y equal to f of x. How do we find, oh, where f of x is 1 to 1, how do we find okay, so there's a method. All right, so here's the method. The first thing you're going to do is switch x for y in the function. The second thing is you're going to solve for y. And then the last thing is you're going to name y F is inverse of X. Okay, this is the method. We're going to switch X for Y in the function. Then we're going to solve for Y. And then we're going to rename Y to be the inverse function. Okay, so here's an example. F of X is 4X minus 1. Okay, now this is a line. And we know a line is going to pass the horizontal and vertical line test. So we don't have to worry about this. So this is 1-to-1. Okay, so I'm going to start with Y is equal to F of X. So we're going to start here. So we're going to let Y be 4X minus 1. So this is our starting point. All right. So the method says switch X and Y. So now I want to switch X for Y. And I'm going to get X is 4Y minus 1. So all I did was change X and Y. I changed X and Y. Now I need to solve for Y. So I'm going to add 1 to both sides. Then I'm going to divide by 4. So I solve for Y. And so now I'm going to rename Y as F inverse of X. So therefore, F inverse of X is X plus 1 over 4. And that's my inverse function. Okay, so let's check it. So we have two things here. The first thing we have is, oh, wrong line. This is my function F of X. And then this is my function F inverse of X. Okay, so let's check. So we said that F of F inverse of F of X. Let's see what that means. So that says take F inverse of, what is F of X? F of X is 4X minus 1. So F inverse of that says take everywhere I see X, I'm going to put this value. So F inverse of anything, F inverse of anything is to take that thing, add 1 to it, and then divide by 4. So therefore, F inverse of that thing is going to take that thing, 4X minus 1, add 1 to it, and then divide by 4. So that is F inverse. I'm sorry, that's what F inverse does. So I don't need this anymore. So now this says 4X minus 1 plus 1 is 4X over 4. And I just get X. So yes, indeed, F inverse of F of X is X. Let's try it the other way. F of F inverse of X says take F of, what is F inverse? Well, F inverse is X plus 1 divided by 4. So F of that says, well, F of anything says multiply that thing by 4 and then subtract 1. So it says take that thing, multiply it by 4 and then subtract 1. But that just gives me x plus 1 because the 4s are going to divide out. Minus 1, and again I get x. So f of f inverse is equal to x. Okay. So let's do something really easy. So let's start off with f of x equaling x cubed. So we said that thing is 1 to 1. It's not a line, it's a cubic function, but it's 1 to 1. So therefore it has an inverse. So we're going to start off with y is equal to x cubed. Then we're going to switch x and y. So now we're going to get x is equal to y cubed. And in order for me to figure out how to, I need to take x and raise it to the 1/3 power. I have y cubed to the 1/3 power. So this now gives me y is equal to x to the 1/3 power, or y is equal to the cube root of x. So therefore are 3 dots. If you've ever seen that before, that means therefore. F inverse of x is x to the 1/3, or the cube root of x. So if I cube something, in order to go back, I take the cube root. All right. So here is my function f. And here is its inverse. Okay. Any questions? All right, let's do something a little bit more difficult. Okay, f of x equal to x squared. Now, we already said that for f of x equal to x squared, that function does not pass the horizontal line test. So we can only consider one part of the function. So let's just say now we're going to restrict x to be in. So now I'm only talking about one part of this. So that piece of the function, oh, I meant to draw the cube root. I meant to go, let me go back. So this was x cubed, and the cube root of x looks like that. Okay, so we see the function and then we see its inverse. All right, so now we're restricting this function x to be in the interval 0 to infinity. So now we want y to be x squared. So we're going to switch them, and we're going to get x is equal to y squared. We're going to take the square root of both sides and get y is equal to the square root of x. So now we're going to call that F inverse. So now this is F, and that's F inverse. So F inverse is going to look like that. Now things can be a little bit more difficult. Okay, so now we have f of x is 2 times the square root of x minus 3. Okay, so this function is a square root function. All right. Can anybody tell me the domain of this function? What values can go inside of here for this function? The domain is the set of all x such that, what do I know about x has to be true?
Has to be higher than 3.
Okay, can it be equal to 3?
Yes.
Yes. Okay, so x is greater than or equal to 3. Okay, so if that's the domain, then that I can only talk about this having an inverse on that domain. That means this function, if this function only exists for x greater than 3, greater than or equal to 3, then this function will not even have an inverse anywhere else. So its inverse will only exist on this domain. Okay. All right. So we're going to start off with, okay, so that lets me know I have 10 minutes left in class. I make sure I start on time and I end on time. Okay, so y is equal to 2 times the square root of x minus 3. Switch x and y, so I get x is equal to 2 times the square root of y minus 3. So I'm going to divide both sides by 2 and get x over 2 is the square root of y minus 3. Okay, what do I do next? I'm doing a problem. I meant to let y'all do some.
You gotta square both sides to get rid
Square
of the
both sides. Okay, very simple. So therefore, the inverse function that's wrong. Okay. So the first function looked like this. What was it? The square root of 2 times the square root of x minus 3. So it looks like that. And its inverse function, I gotta flip this thing. I don't know if they touch. I don't think they touch. Okay. All right. Last thing, our trigonometric functions. Please read the section. Okay. So we know the sine function So our sine function looks like okay, so here's the sine function, sine of x. Okay, and so this here's 0. This is pi. And of course, it hits at 2 pi over here. This is minus pi. So clearly, the sine function does not have an inverse because this thing fails the horizontal line test. But we can define its inverse function So we'll define its inverse function, and it's going to be only defined on the interval
Zero to half pi.
no, we do it minus pi over 2 to pi over 2. From here, we're going to cut it off here. And we're going to cut it off where this actually should be, which is not. Right here. So we're only going to take this piece. And on that one little piece, the function is 1 to 1. So we're going to take this on the interval minus pi over 2. And I think we're going to include the endpoints. To pi over 2. Okay, so we have what we call the sine inverse function. I have only a few more minutes, but Okay, so the sine inverse function looks like that, and its inverse looks like that. Oh, that's wrong. That's right. So it's inverse function. So this right here, the blue line, is the sine inverse function. Okay. How about the cosine? So f of x equal to the cosine of x. Well, if I draw the cosine of x, so the cosine of x looks like this. Again, something that would generally fail the horizontal line test. But we can define f of x to be the cosine inverse if we restrict it to just from 0 to pi. So we're going to restrict it. Okay. So we're going to restrict it to 0 pi. Okay. Actually, I should do a better picture of this. I don't like this picture. I don't trust it. It needs to be really drawn right. All right, so we are out of time. There are 6 functions. So there's the sine of x, the cosine of x, the tangent of x, the cosecant of x, the secant of x, and the cotangent of x, all of which have inverse functions. So I want you to look at the section and see what the pictures of these things look like. They have them very nicely drawn. So they're drawn with their intervals and everything. Okay. You should, if you are not enrolled in Edfinity, you will be within the next few hours. I know that they are working on that. Okay, any questions?
So what do we do about attendance?
What do you do about exams?
About the, what do we do about the attendance? Because
Oh, so I'm going to go back and into the attendance.